Check out what I have here, the FORZA ONE head. Today we're going to take it apart completely, down to the last screw, and learn how it works. This is the black 1500 head, or B-1500, made especially for FORZA Laser, for the FORZA ONE machine. And well, here, the head, what's the function of the head? It's to condition the light. The light, or the laser, is generated in a resonator in the laser source, which sends the laser through a fiber optic cable all the way to the QVH connector, which is this one. The light is conditioned internally. What does that mean? It means the light starts out as a cone spreading outward. Then, in the collimator, it's conditioned to go down as a cylinder. Finally, in the focusing lens, you can make it into a cone again, like a magnifying glass, and be able to concentrate the laser into a point so small with enough power to cut. This happens as it passes through this whole conduit, and finally the laser comes out through the tip. Let's section the head so we can explain it better, part by part. First, we have the initial part, where we have the QVH connector here. First, well, the cooling stage, which is the part that will get hot. Over here, a protective lens and the electrical connectors for the servo motors, limit switches, and other parts. From here, in the central area, is where the heart of the head is located. Here is the collimator and focusing lens, which are very delicate optical systems and absolutely no dust can get in. We also have the capacitance system, which is this sensor here, which is the one that it conditions the signal so that the head knows at what height the material is. And finally, there's the output part, where we have the nozzle, which is the part in contact with the material. And, of course, the laser output as well. Here there's a chamber that combines the assist gas, whether it's oxygen, nitrogen, or compressed air, together with the laser, since the assist gas removes all that material that basically melts and helps me make the cut. Here I also have protective lenses that prevent sparks from entering this delicate area, and so, in general, these three sections. And before starting to disassemble all the parts, I'd like to talk about the systems that make up the head. First of all, the head has a capacitive control system, or capacitive sensing, which is made up of this signal conditioner. This cable, some internal conduits, and also the nozzle are part of this system, and it's what reads the height of the head. It does this in relation to the material, and it does it throughout the entire job. It does it continuously. Another system is the cooling system. As you know, the head needs water cooling. Why? Because the lenses start to heat up. When light passes through certain lenses, thank you, only about 97 or 98% of that light actually passes through. That remaining 2% turns into energy, into heat. And well, if we don't cool it, they could end up exploding. That's why it needs a cooling system. That's the other system. Basically, there are conduits that carry the water and cool this aluminum part. Another system, which is the main part, is the light conditioning system, which is the focusing system. And the collimator, which are the main lenses, the heart of the head, that are inside, and they modify the shape of the light so it comes out exactly as we need it. A fourth system is the gas system. Basically, let's remember that the head also combines the assist gas with the laser at the nozzle. So, here we have a chamber where it receives oxygen, nitrogen, or compressed air and allows it to exit properly through the nozzle. And finally, a protection system for this core. So, here we have a chamber where we will have protective lenses. 2 lenses at the bottom and 1 lens at the top, which basically prevent any spark or dust from entering the central part. So, this is our protection system. And one last system I'd like to mention is the electrical system, which is basically the servo motor that moves the focusing lens, the limit switches, and some other electronic components. First, we're going to disassemble this last part where they are. all the components of the capacitive sensing system. And here we already have all the parts of the capacitance system or the capacitance sensing system. Basically, it's a signal that's taken at the nozzle. The nozzle is also part of this system that reads the distance between the head and the material. This distance, which is measured through this capacitance. This signal is carried, then, through these parts, first by this ceramic piece. Sometimes it's called a capacitive sensor, but really it's just a piece that holds the nozzle and carries the signal through this little dot or this yellow contact, which is made of copper, to this piece, which is already the first part of the aluminum block. Inside, it has a cable that carries the signal to this connector, and then this connector to this cable, and finally to the conditioner. So, it's a signal that travels through all these components, gets conditioned here, and from here goes directly to the controller. This is the system that allows the head to know where the material is, and if it hits it, it will be able to. A pause. An important observation is that the sensitivity of this system allows me to react quickly to the machine so I can pause and avoid it from hitting. This system also depends on servo motors that can quickly lift the machine, which is why it's important to understand that this isn't a separate system, but rather just a part of the whole set of equipment so that it works properly. And now that we have most of the parts from the final section out, let's continue with the gas system, which is basically this inlet where oxygen, nitrogen, or air enters, and a chamber. So, well, let's disassemble it. And this is the gas system. It's pretty simple, really, because, well, first we have this connector here where oxygen, nitrogen, or compressed air enters, depending on the gas we're using, into this chamber. This chamber obviously has a little cap, so you can close the chamber. Here, what prevents the air from going toward the head is a protective lens. And so the gas exits through this whole opening. This opening channels it through this second piece, where we simply have a second conduit, to finally end up at this smaller opening where it connects to the nozzle. The nozzle is what finally redirects the gas toward the exit, toward the material, and remember, its function is to push that material that's already melted so the cut can be made. The laser evaporates it, melts it, but the assist gas removes it, detaches it from the material of the piece, and that's how it's done. The cut. Next, we're going to, well, we almost have all the parts of the protection system out. So we're just going to carefully remove this upper protective lens and then look closely at the essential parts of the protection system of these specialized lenses we previously mentioned, which effectively prevent any dust particles, sparks, or other contaminants from getting into the very heart of the laser system. And this is the protection system. Basically, it's 3 lenses that prevent dirt from getting into the sensitive area, the central area, where the focus is, the collimator, where the heart is. First, here we have the lower protective lens number 1, which is basically the one that has access. The operator usually opens this little cover, and here goes the lens, this lens. And usually this one gets pretty dirty, because it's the one in direct contact with the sparks that come in, either through the nozzle, due to the pressure, or because of the force. And it gets replaced. That's why, in a simple way, if for any reason or if this lens happens to break, well, there's a second barrier, also on the lower part, which is this second lens that, if necessary, we also replace. But for this, you already have to disassemble the head, and it should be done by, let's say, specialists. And on the upper part, we also have another protective lens that prevents any debris that enters through the QVH from getting into the collimator. An important point, here we have the head open, but that's because these lenses are no longer usable. If we were handling the lenses like this, and they were still in good condition, they would automatically get damaged just by coming into contact with our fingers. This is the cooling system of the head. It's quite simple, actually. There are just 2 of these connectors that go into a water recirculation chamber to keep it at room temperature. This part of the head is the one that tends to heat up the most. In this case, there's only one stage of, let's say, additional cooling to the QVH. Remember, the QVH is this piece that comes from the source, from the laser source. It connects here, and there are also some cooling ducts here, but that's part of the source. In our head, it's just this chamber. Depending on the size of the head or the power, you'll see that these cooling systems also cool other parts. If we're working with a head, for example, the Ritus BM111 or BM110, we're going to have 3 cooling stages. Similarly, as long as the heads are 6,000 or 12,000 watts, they're bigger because they heat up more and need more cooling. In this case, since it reaches 1,500 watts, we only have cooling in this part, which makes it very efficient, lightweight, and allows us to speed up and move at higher speeds. And now let's move on to the heart of the head. Don't miss the second part of this video. Subscribe and turn on the notification bell.